Welcome everybody. So happy to see so many people here on site, and hopefully some of the people on the stream will also enjoy this presentation. This is my lecture about Unity optimization. I called it universal because I'm doing talks about it since, I don't know, 2017 maybe, and 90% of things I talked about then actually still viable. Of course, engine developed tremendously, but I'll try to show that there are universal problems at its core, and we'll probably have to be aware no matter the version, what the version would be. I've retested all of those optimizations on Unity 2020 LTS, but I don't think they'll invalidate much in future versions. So this is my agenda for today. After introduction, I'll go over characteristics of Unity engine, why should we optimize and when we shouldn't, something about memory management, CPU fun bits, GPU fun bits, something about object and assets management, some dirty settings tricks, and after summary, we'll have a Q&A session. So, premature optimization is root of all evil. Those are the most misquoted words in IT, famously said by Donald Knuth. Why misquoted? This is the full quote, and I think it sounds differently in the full version. We should forget about small efficiencies about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our opportunities in that critical 3%. So we'll go over those 3%, at least in some pinpoints. So I'll try to refer both to small and big efficiencies and inefficiencies, and I'll focus on those rather quick changes, not some big reorganization of the whole project, because we don't have that much time, and many pinpoints I'll be talking about actually could be spread around the entire hour to talk. So I'll try to be quick on my feet here. And where? If you're wondering who I am, I work long enough in this industry to see some things. And those are companies I worked for. So let's start with basic info of how Unity operates, which will show why we love working with it. And at the same time, we might have some efficiency problems. So a common way that gaming people measure performance is with frame rate, or frames per second. This can be a deceptive metric, because when we're gouging when we're gauging application performance, try using frame time instead. If your game is running at 900 FPS, I don't know whether somebody actually achieved that, but still, this translates into a frame of 1.11 milliseconds per frame. At 450, it's 2.22. And so the difference between those two is only 1.11 milliseconds per frame, even though the frame rate appears to drop by 1/2. If you look at the differences between 60 FPS and 56.25, that translates into 16.66 milliseconds per frame and 17.77 milliseconds per frame, respectively. So this also represents the difference around 1.11 milliseconds extra per frame. But here, the drop in frame rate feels less dramatic, right? At least percentage-wise. This is why developers use the average frame time to benchmark game speed rather than FPS. Don't worry about FPS unless you drop below your target frame rate. Focus on frame time to measure how fast your game is running, and then stay within your frame budget. What is a draw call? Is the call from CPU to GPU to draw some object. Depending on the complexity of given object, we use multiple draw calls to render this given object. So when you use unique object with 4 materials with single pass, where textures are on different atlases, then you have to use 4 draw calls to draw said object, in of course, the most simplistic case. So all of this complexity forces CPU to prepare all required data before dispatching it to GPU. What should be done about it? Reduce the number of draw calls, right? By simplification and batching. So, game objects and components. Unity uses, of course, object-oriented architecture where each single object is treated individually at its core. So we have object, for example, a car with all its properties and mechanics, and each car has its starting phase, update phase, rendering phase, and so on. This is all according to our intuition, so it's fine, but also causes basic overlap problem when we have to wander around the memory to find the car, its properties, call each component methods, and so on and so on. So this may cause, on a bigger scale, a tremendous redundancy. So this image might paint it better. We waste CPU cycles just to access given data and call stuff. So even an empty method within given mono behavior can en masse cause performance issues. So since we do it each frame, we have to be aware of that. Garbage collector. So Unity employs automatic memory management for user-generated code and scripts. Small pieces of data, like value type local variables, are allocated to the stack. Larger pieces of data and longer-term storage is allocated on managed heap. So the garbage collector periodically identifies and deallocates unused heap memory. While this runs automatically, the process of examining all the objects in the heap can cause the game to stutter or run slowly because it's Bem Demers Weiser garbage collector, so it stops the program's code until his work is done. We can control that process, of course, so the less work garbage collector has at a given moment, the smaller stutter happens. So we can attempt to control this process. Also, we can try to use incremental garbage collector, which mitigates the problem a bit because it divides the GC workload between frames. But generally, the less we use garbage collector, of course, the better. Profilers. So this is like the standard look of the Unity profiler. We have lots of modules there, and it's worth to start getting familiar with it early and often. Always try to profile before introducing any optimization. Do not optimize blindly. Try also to profile on target device, or at least use emulators. For mobiles, actually you have that possibility. With other platforms, not so much. Also, the weakest platforms should be our point of reference. Right, so GPU bound versus CPU bound. Determining where to focus our efforts is also very important. So look into profiling events which marker is showing up most frequently. If it's GFX, wait for commands, or camera render, then actually GPU is ready to work, but CPU is overloaded, so it's a bottleneck at a given moment. And on the other hand, when you have GFX, wait for present or present frame, marker that's dominating the profiler, then GPU is like a troublemaker, right? So when you have problems with accurate measurements, you can also try to do deep profiling. It will help you get more accurate data at the cost of the general performance. So we have certain pros of our Unity engine, right? So logical structure according to OOP, out-of-the-box approach, very easy, right? Easy management, easy setup, easy prototyping, easy deployment. It's free, awesome. We have large community and lots of free stuff. So this is everything we love about Unity. However, since it's a closed architecture, there is a problem when you find some bug, it's hard to get into it, localize it, and report it properly to authors. And it's rather slow support, in my opinion. Conversion between major iterations are pain in the butt. Lots of stability problems happens, especially when we upgrade, even between minor versions. When we scale up the game, so we use, in basic approach, of course, when we use more units, for example, that we prototype at smaller scale, then we can have lots of problems with proper processing of that many units. So this is also a thing to consider, and maybe this is also problematic if we use this basic approach and not data-oriented tech stack. So why should we optimize and when we shouldn't? Of course, this allows to solve early stage problems when we optimize, and this is why we should do it. It helps to bring out less obvious problems. It shows closer to final version of the product, so we can, for example, test it better and quicker. And regular refactoring and optimization sweeps helps to reduce technological debt and weight. So to explain, technological debt is something that bites back when we say at certain moment in the development, oh, well, I can leave this problem today, let's tomorrow we handle it later, and we never do. And that's why then at the end of the given production run, we find out that there are lots of inefficiencies that are hard to fix. Technological weight is a working functionality that is so hard to maintain and change that nobody touches it, but rather goes around it because any change causes entire game to collapse. So I think this also, I saw this a lot. So when we have that kind of colossus on the clay legs, this is quite troublesome. When we should optimize. So in terms of the code, early and regularly, after approved prototype of given functionality, we can attempt at least a few optimizations. After closing a bigger production stage also, and when it's required because we have some performance drops, and we have to give this version to, for example, a publisher, then sometimes we have to optimize it before given stage is closed. When we want to optimize the assets, well, this is a problematic thing, and most of the time it's better to optimize it after content freeze, so much later in production. But sometimes it happens, especially I stumbled upon this in regard to meshes. Some things are added on the way and might be high quality, high poly meshes, and they can hamper the performance. So if those assets happen to show up, we have to, at least for a given build, for example, we want to prepare, we have to optimize it. When we should not optimize. So every time the gain is smaller than the cost of given solution. So just before milestone, when touches the game foundations, no bueno. Sacrificing stability or increasing possibility of regression also not recommended, right? Even when we are prototyping. When we cooperate with others, it's rarely to create game by our own. We should not sacrifice modularity and readability because somebody else might work on certain piece of code later. Also, it happens that we might need to go back to a certain piece of code like 3 months later, and then when we go through that unreadable mess, it's also harder for us to fix anything. So we shouldn't sacrifice readability for small gains. Also, when it's some kind of irreversible process, because we have lots of interconnected elements, we shouldn't also touch that. And of course, when it's too costly for given gain, it's maybe sometimes better to raise performance by 3% if it costs 1 hour of job, than 5% and it costs, for example, a week of our work. All right, so to more specific things. Memory management. Optimizing your memory usage means being conscious when you allocate and deallocate managed heap memory, and how you minimize the effect of garbage collection. So when you have lots of small, I was afraid that it might be not so visible, but seems to be okay. When you have lots of small locations, you can call GC sweep every second if it won't keep your efficiency in the game. Sometimes I saw this solution on some mobile games. When you have large allocations, you can use moments like entering pause screen or sleep mode to sweep up memory. Then strings and boxing. This is the most common problem. I see it in like every Unity project. We should be mindful about string concatenation. This is a very popular operation, very often overlooked. Each instantiation of new string creates new object on a heap. So try to minimize that to the farthest extent. Use, I don't know, string builder, for example. And with boxing, there is also other related problems. So going through collections, do not create new ones if you don't have to. It's better to cache or even reserve a block of memory and then erase it and refill it again instead of creating a new one. When you go over the list capacity, we create new chunk of memory. And when we clear the list and then in the next frame create the list again, we're making GC to work on it, which can and should be omitted. Lists and map access, also this is connected with boxing. When you're using large dictionaries and do it often, create your own comparer which won't produce new objects. Also, this might be, of course, controversial. Some might say there was a fix for each. I think the most beloved way to traverse the collections. But still, actually, officially in Unity documentation, they do not recommend using it. So in my opinion, it's not so hard to write like the old school way of for traversal. So yeah. Also, don't use link. For the love of gods, whatever they might be, don't use link, because almost every function uses some kind of boxing and it produces lots of garbage. Getters. Even though engine API classes are well optimized, some of them still might be better to be cached before usage. At some point, and this is probably has been fixed there was advice to even cache the transform of current game object. So the transform object, which is like the most popular one, was actually advised to be cached, which might sound crazy, but I don't think that this is like a lot of job to be better safe than sorry. Non-alloc methods. A few computation-heavy methods have non-alloc versions. I really recommend using those. They are not so hard to manage. You just need to allocate big enough arrays or other collections that might be required. It really makes a difference, especially like writecasts that are really heavy methods. And in one game I was porting to Xbox One, actually changing because there was a lot of shooting, a lot of deflecting bullets, and so on, so on. So when we changed the approach to non-analog, actually we gained a tremendous amount of performance, like in terms of course being in the late stage of production. It was like, I don't know, almost 10%, I guess. So it makes a difference to stabilize this kind of runs. Coroutines. This is like the most one of the most popular problems, and actually never saw a single company that was taking this into consideration. Do cache coroutines conditions. Each call yield new blank is creating heap object, and you can just cache it. So coroutine heavy projects, in coroutine heavy projects, it also makes a difference. And of course, the queen of all, CPU and memory management, object pool, design pattern. Wherever you can and you're doing things en masse, if you're reusing objects of the same type and do not instantiate it, please do not instantiate it by hand or create it from scratch. Create a shared stub stored as a prefab, then make a pool from it large enough to your needs and just spawn, despawn it at your disposal. You can create that pool gradually after initial start. I leave the I have the link at the end of the presentation where you can see, for example, the lazy initialization of object pooling and so on. Also, because I've noticed that you're doing the photos of slides, you don't have to. At the end of the presentation, you'll have the link to the full PDF version of this presentation with all the links and so on, so you can download it on your mobiles or just make the photo of that one and find it later to download. Yeah, so CPU fun. Let's go to more CPU related stuff. So the absolute basics, like you should memorize it, print it, hang it over the bed. The strange thing I found was with this camera main call. Up to version 2020.2, actually camera main accessor was really heavy because it was using some kind of search over the through the entire scene. I don't know why, but actually it's quite funny. And another thing, do not use heavy methods like GameObjectFind, getComponent, and so on in updates. This is like programming in Unity 101. And try to not call addComponent at runtime. Use prefabs or cache it before or something like that. So this is like the simplest template to not overuse those heavy methods. Also, since debug log is quite heavy, and during debugging or local testing, we do like our detailed reports, right? We should cut it out in targeted build. This is an example how to handle it. Generate your log message with custom class. If you disable the enable log preprocessor in player settings, all of your log statements will disappear like in one swoop. So why not use that? If you're feeling fancy with CPU, then those things are important but can show up its worth mostly on a bigger scale. So try to not compare directly with null. Use comparers that were prepared by Unity. Choose wisely your update methods. Optimize math expressions. Take notice how you create math expressions. Instead of dividing float by 2, for example, multiply it by half, right? So it's a cheaper operation. Also, if you can start from simpler types first, some expressions might be optimized at compile time. Jagged arrays, so arrays of arrays, if I'm, yeah, I think I'm right with it, were proven to be a few times slower than regular ones, so, but they're faster than multi-dimensional ones. So actually, I haven't met any project that was using like typical multi-dimensional array, but still it's worth remembering not to use it. Variables declared as const or static read-only will be inlined during compilation. This makes sense, of course, only when we absolutely do not need to update logic every frame. Also, it's worth to separate mono behaviors into groups, and each group might be run at different moment of that interval. We can split it by, I don't know, 3, 4 groups. That might even out the computation load quite nicely. If we are sure we don't have to update every frame, this is really quite nice way to optimize your game very cheaply. Also, if you can pull that off and you don't want to meddle with dots, you can take your computation-heavy components and regulate their update routine manually by creating own manager that has its own mono behavior tick but controls others. This can be implemented in multiple ways and in a bigger scale may provide significant performance gain. A bit of GPU. So it's worth to consider using different built-in rendering pipeline. If we don't feel comfortable in customizing our own scriptable rendering pipeline, it's worth to choose either URP or HDRP. Static batching, so like the simplest way to optimize, as name indicates, should be applied to non-moving objects on the scene. It's fairly easy to set up and use. The only substantial drawback is that it's memory heavy. When we batch large group of meshes, it can bite in the butt. Dynamic batching. This works automatically on small objects if they meet the conditions. You'll see in Profiler that batching setup might be sometimes CPU heavy, but in return we may save a lot of resources, so it's worth doing it. Also, it won't work at the same time with graphics jobs. Graphics jobs utilize multi-threaded draw call setup, which may be better for AMD-based consoles, so PS4, PS5, Xbox One, Xbox Series X, etc. So yeah, try to use that. Like I said, test frequently, and probably this is one of the cheapest and also a significant attempt when you're porting games to consoles to actually test whether graphics jobs will help in your project. GPU instancing works well only when you render lots of the same objects on the screen, but still it's worthwhile to think about it, and it needs only a single tick on the material. So there are some other conditions as well, because I think transparent materials won't work. Sometimes there is a problem when you use light mapping, but still, yeah, no light maps, yeah. But still, it's worth to attempt to use that optimization. SRP batching. SRP batcher is fairly new magic trick that uses new approach to draw call setup. It can be only used with URP or HDRP, so this also might be quite beneficial. General tips. A lot of those tips could fill up the whole lecture on its own. That's why I'm leaving links to some tutorials for you to check. I was wondering at some point in the past why render dot material shouldn't be used and shared material should be used. I knew that it was creating a new instance of the material, sure, but I didn't know that it also breaks batching, so don't use it if you don't have to. Objects and assets management. First thing about asset settings, experiment. The utter goal is to provide the best performance for your game at the minimum loss of quality. Those are general things useful not only for programmers. Still, it's good to suggest to non-technical part of the team that might not be aware of some of the settings that without much loss they can contribute to better games performance. So this is, I think, very important to raise those problems with other members of the team. All of those options are presented, are visible in like import settings or specific assets or some settings in the project. So, but first, hierarchy. This is also quite funny thing. Transforms on the scene should be split into many hierarchies instead of one common root parent. From Unity 2018.1, Unity has jobified the way transforms are processed, so the less parented and less reparented operations you have, the better. This is because each root object on the scene has buffer to its children and keeps check on the moment some things happen in their transform. Each transform has a dirty bit mask that, if gets changed, causes traversal of the entire tree starting from given root game object, which can be costly. That's why it's better to split it up. However, each root game object checkup is jobified on threads. So the more split up hierarchy we have, the better. This applies not only to UI, because this was like the first thing I heard to be like a proper, more efficient approach, but it applies actually to all game objects. Utilized delayed sync transforms on physics operations. From 2018.3, synchronization operation is delayed to the latest possible moment instead of being called right after the transform change. That allows us to run in batch transform operations first and then physics-related ones. And actually, it allows us to gain a lot of performance, especially on less nested hierarchies. There was this talk at Unite 2018, where they showed that they had 1,000 empty game objects and 100 cubes that were rotating, and they just changed the way how they are organizing hierarchy. One was parented, and one set of objects was completely unparented. And this unparented was actually a few dozen times faster. So yeah, it's really worth to explore that idea. Also, audio sources should be deactivated and not muted if not used. Muted component, especially audio component, is still running and being processed. Same goes for rendered objects. If properly approached, we can cut a lot of heavy logic if the object is not rendered. If we can do that, thanks to on became visible invisible events. Okay, so a bit about assets, textures. It's where to go over those assets and tune them up according to the target platform and disable unnecessary settings. What is more, try using texture atlases. It will allow more objects to be batched, organize assets better, reduce loading time as well, so it's like beneficial all the way. With meshes, just also strip all of the settings you don't need to. And actually, I think we all probably heard or lived a story of some stadium dome used as a fruit bowl in a room. And this is, at least I was going through that kind of event. We worked 2 weeks on optimizing everything else. And then I think QA found that there was like a fruit bowl made from over 100,000 polys, And this was like a really old game and so on, and it was a few years back. So that kind of poly count really mattered. And actually, this was like a horrible thing. Designer just took some sports stadium dome from the internet and scaled it down to the football and left it on the table. So yeah, that was horrible thing. But we optimized the hell out of this game, so maybe that was beneficial in a way. That is why it's always good to do an asset sweep from time to time, check what can be reduced, optimized, and remember about a few options that might be enabled, disabled in the settings. Regarding the audio, Vorbis with streaming saves saves memory for CPU and loading from disk. When compressed in memory, we do not save the memory, of course. Decompress on load takes the biggest chunk of space, but least CPU occupancy. Most of the time, quality set in range between 70 and 80% is barely noticed, so this also might save some space. Any dire straits fun? No? Okay, so that's how being old feels. What can we do in settings that might improve performance significantly with no effort? Player. Disabling unused APIs allows to have smaller build size, reduces build times, reduces unnecessary shader variance, blah, blah, blah. After prototyping phase, try to switch to IL to CPP. This may increase build times tremendously, sadly, but provides overall better performance. I leave in bibliography tutorial how to mitigate build times problems. Quality and graphic settings. Not the big philosophy here, reduce settings quality to the point it won't impact your game terribly, and if you're shader heavy, try using shader variant collections. This pre-baking and warming up shaders actually sometimes might really help. Physics. Here you can mess things up, really, but also gain a lot. I already talked about autosync transform, disperse hierarchies, first to do the transform operations, then physics API calls. You can call physics sync transform if you need manually. Always plan properly the layer collision matrix. It will save you a lot of time later. Meddling with time steps and solver iterations might be a risky fun, but test each change to be sure you're not causing chaos in your project. Still, you might also gain a lot through that. Okay, that was quick. So to sum up, I hope this was an interesting set of older or new information, how you can optimize your games. As you can see, most of the stuff is quite simple and effortless. Not really connected to specific, with some exceptions, not really connected to certain Unity version. So I think it's worth to consider those steps in your project. The Q&A session. For Q&A time, I'll leave the takeaway and job offer link if you're interested, and you can start with questions. Of course, photos, yeah.
Hi.
Hi.
I think it's removed. Okay, so basically, what is your tip for testing performance of your game if you don't have an access, for example, to an older computer? You have a pretty powerful machine and you want to make sure that it will work on the biggest range possible. Nowadays, we also work in remote and don't always have access to this kind of machines. So what can you do before, if you have this access to the machines limited, so you can be mostly sure that it will work fine?
There are some emulators you can have on PC. You have those programs that may slow down your CPU, for example. If you will measure the frame time, not the frames per second, it also might help to deduce that for any other machine given change might be beneficial or not. Also, older computers are not so expensive, so you just go over the used second-hand CPU stores and try to invest.
Nowadays, all chips are expensive.
Yeah, you got that right.
Thank you.
So you said, sorry. You said you were talking about not using parenting much.
Mm-hmm.
How do you deal with tons and tons of objects on the scene without, having imagine having a problematic object appearing, like exploding enemy, right? And it's like number 10,011 out of 10 billion objects. How do you find it? How do you deal with that?
Yes, this is the main drawback of that solution, that it can really create chaos. I'm not sure whether Unity provides some categorization or there is a plugin for it that might add some property to the object that will make it better sorted out on the main scene. But still, yeah, this is like the biggest drawback of dispersed hierarchy. You can have like total chaos on the main scene view.
Hello. So you have proposed the iteration approach to optimization. I'm curious what you think about optimization at the end. So this is in the context of the lost man hours. When you optimize and then the new engine version comes, or something changes, or for example, the client requires a big change. How would you defend this approach in this context? Wouldn't it be better to, optimize at the end?
Thank you for that question. This is like, there are optimizations and optimizations, right? And some of those are mostly maybe regarding to organization of the code, which might be universal no matter the Unity version, right? So, for example, factoring out the code, checking out the math expressions and so on. This is like universal stuff, no matter even the language. So this is definitely worth doing regularly. Some of the technically specific stuff, I would agree that if you're planning to do like major iteration upgrade, and this is like connected really deeply into given version, you might postpone it to the later phase, sure.
Thanks. And another one. How do you educate your programmers in the studio so that they all know about this, those nitty-gritty stuff?
Regularly talking about it. We tend to have a bit longer daily meetings where we share ideas and just ask, no matter the seniority, whether given approach is okay. We do I think every commit, maybe 95% of the commits are actually going through a code review by 2 other people, also no matter the seniority, because we have to train even the junior staff to know how to properly assess the code. And those things, by example, by slow, with the slow steps, actually creates proper habits to create a quality code.
Thank you very much.
Hello. Did you try entity component system as a main approach to the development?
Oh, this is like music to my ears. Actually, I'm really the ECS freak. I really do like this data-oriented approach, and I think this is like the most underrated architectural system to let me rephrase it. I just really like it. I do try to promote it. I didn't mention it practically here because I did a GIC talk in 2019 about it. So you can go find that. And actually, I'm trying whenever it makes sense to try and implement it because it's still in development phase. Still, it's being tested. Not everything works perfectly, but if you're doing a large-scale game, I would definitely recommend using this gold trio, I guess, the ECS approach, data-oriented organization of the code, the job system, and burst compiler.
Thank you.
Hello, I have a continuation of the previous question about dots. So basically, would you recommend using dots in actual production? Is it like in preview right now? Or maybe other solutions for entity component systems that you would recommend?
Sadly, I haven't got with any game I worked on to the stage that we actually could use this in final production. We are always experimenting. I'm doing some testing. I'm doing some prototypes, but I haven't had this experience of doing like final product with ECS, sadly.
Do you have any other maybe implementations of entity component system that you would like to recommend for using in production?
I read about a few. I don't remember the name, but the one guy made ECS system before Unity launched its own, and from what I was testing and playing with a few years ago, it was quite good. I'll reach out to me later, and I'll try to find it out, and I'll send you the link.
Okay, thank you.
Hi, thank you for the great talk. I was wondering if you have any specific workflow for different platforms optimizations, because optimization can be like platform specific. For example, your main goal is to develop game for PC, but you have to also like optimize it for Switch. And for example, when are you starting to thinking about different platforms, and also do you create different branches for different platforms and then try to maintain it, or how do you manage to make all these things and do not lose with it?
Thanks for that question. With consoles, first thing, if you know that you're doing multi-platform game, think about it from the start. So prepare your code, prepare SDKs if you can, organize the build. So if you switch platform in your Unity editor, then the proper libraries will be swapped and so on. Do code branching for platform-specific things, obviously. Try to create facades for common functionalities that might have platform-specific solutions. There are many common changes that you can do only with PC, but at certain point there is this time that you have to test out platform-specific stuff. And You have to count it into your hours. I think the fast as you can. The fast as you can, give yourself, for example, I don't know, hour or two per week, just to go over how this might work on the console. Try to create like this initial, even empty project build if you have a given target platform. Or the moment you receive the dev kit, just try to create build from what you have, because I saw this many times that they knew the company knew that there will be multi-platform game. They had already the dev kits, and it was collecting dust for 3 months, for example. And then they woke up, Jesus, we have to do a build for console in a week. And then there was like all of the possible hells, because they had basic build problems. They created pieces of code that is not compatible with given platform, and so on and so on. So plan this as early as you can. Count it into your week hours to think about it even, and create this basic build as fast as you can. Okay, so I said we have this one question. Why do you recommend using incremental GC only as a last resort? Is it because it's relatively new, or because it encourages bad practices? Both. But still, for a long period of time, incremental GC was experimental. Now probably it also is experimental, but they just changed the label. However, I haven't seen much of the stability problems with incremental GC for a while. So this is just, in my opinion, lazy approach or last resort when you don't have time to manage your memory properly. So yeah, like I said, both. Any more questions? No? Okay, so can we see slides for a bit? Not? Oh, okay. So, thank you for your questions. There were quite interesting ones. You have links. All of those will be downloadable for you. I hope you made already pictures or just copied the link. Thank you for your attention. Here you have some contact info. Feel free to reach out either through my socials or personally. I don't bite. I'm fully vaccinated, so no worries. Also, if you're looking for people on multiple, we're looking for people on multiple positions, so visit our website or again, reach out to me personally for the further info. Thank you and take care.